Hi, this is Pluripotent Scalpel. Welcome back to the part 2 of fracture healing. Uh, in this talk, in this part, it is essentially going to roam around what is direct fracture healing. Before talking about direct fracture healing, let's take a quick recap of what we discussed in part 1. So essentially, part 1 was firstly started with the definition of the fracture. The definition of fracture was the breach in the structural continuity of the bone with degree of damage or injury to the surrounding soft tissue. Then we talk about the stages. There were 5 stages. 0, which is stage of injury and hematoma, where the fracture actually happens. Stage 1 is stage of inflammation. What to learn in this stage was neutrophil was the first cell and the most active cell. Cytokines come, which causes the painful stage. What are the cytokines? Mostly inflammatory, interleukin 1, interleukin 6 and other. Then it's B cell which comes, then the T cells which comes. Then the stages of soft callus, which is stage 2, which is stage of soft callus. In this stage, soft callus chondral deposition happen. 2 genes to remember, one is SOX9 and one is TGF beta. Third stage is the stage of hard callus where bone ossify. Fourth stage is the stage of remodeling. Here the cell was osteoblast and here the cell was osteoclast. Then the discussion was roaming around indirect fracture healing. Indirect fracture healing is also called a secondary type of fracture healing. And it occurs with callus formation. All the stages, it goes through all the stages and occur in relative stability. And it is biomechanically superior. Now, direct healing is different from indirect healing, that it doesn't go through these stages of callus. It occur without callus formation by membranous ossification. And the mechanism how this membranous ossification occur in the fracture bone, I'm not talking about membranous ossification in the flat bones like clavicle during the maturity, which happens when the bones mature. I'm talking about membranous ossification happening at the fracture site. It occurs under absolute stability and by a mechanism which is called cutting cone. Okay. Indirect fracture healing occurs by endochondral ossification, while membranous ossification occur in direct fracture healing. Direct fracture healing is also called as primary kind of fracture healing. So what is this is essentially we're going to talk about in this video. When I decided to put the fracture healing as a talk, I decided initially to put 2 videos, but the second video was going too long if I accumulate factors also along with it. And secondly, the factors affecting fracture healing is actually a more of a theoretical topic. It's not that much that interesting, so and also the video is going too much long. So I have divided it into 3 parts. This part is essentially going to talk about direct fracture healing only, and factors will gonna come as a third part, and it will come today only. I'm recording both of them simultaneously, but it will come as another video. So what is direct fracture healing? Direct fracture healing occur in condition of absolute stability and by direct osseous remodeling without callus formation. These are the topic which we know. It doesn't go into a callus stage or a soft callus stage. It occurs under absolute fracture stability. Now, how it happens and what actually happens? We'll come back to this diagram after seeing the next slide, and then I'll tell you what makes what. So this is a diagram from Netters. If you stay with me for next some time, you will understand that I'm a fan of Netters. It has made my life so easier to understand how the anatomy is and how what is happening where. It makes beautiful diagrams, and one of them is this diagram. So it is showing that it is absolute stability at the fracture side which has achieved by plating, and a macroscopic view of it showing this is one fragment and this is second fracture fragment, and the bone is growing from one fragment to another fragment, and the mechanism by which the bone is growing is the mechanism called as cutting cone mechanism. What happens is the osteoclast from the one bone continuously eating the dead bones of the another bone. From the one fragment of the bone, the osteoclast is eating the dead bones of the another fragment of the same bone, and osteoblasts are laying down the new bone. So it's the osteoclast which cuts and is the osteoblast which lay down the new bone. So back to this diagram, it's the osteoclast which comes at the center of the cone which actually cuts, and is the osteoblast which builds, and is the osteocyte which gets mature. So this is essentially what is cutting cone. It occurs in direct fracture healing, also known as primary kind of fracture healing, different form of fracture healing rather than the indirect fracture healing which goes through 5 stages which we discussed in the last video. Now we talk about this topic, that absolute fracture stability. How does absolute fracture stability achieved when we are doing can be achieved surgically is the question. Now the absolute fracture stability can achieve either by a leg screw or by plating, or there are or by plating with a neutral screw at one side and eccentric screw at another side of the fracture. These topics will be deal in detail when we talk about fixation. When the video will come on about the fixation principles of plating, screws and nailing, we'll talk about in detail what is leg screw, how it is inserted, where it is inserted, and indications and all those stuff. And also the various plating, what is neutral plate, what is compression plate, what is buttress plate, what are eccentric screws, what are centric screws, how to achieve compression at the fracture site. We'll talk about everything in detail. But for now, to understand, the one word which could be understood is a leg screw is a screw which is inserted at 90 degree to the fracture line, hence can only be inserted in oblique and spiral fracture. So this is, say, the distal fragment of the fracture, this is the proximal fragment of the fracture, and this is the fracture line. So you insert a screw in a reduced anatomical position of the bone, in a desired reduced anatomical position of the fracture at 90 degree to the fracture site to achieve the compression at the fracture. This screw, which is inserted at 90 degree to the fracture site, is called leg screw. It inserted at 90 degree. That's why it can only be inserted in spiral fracture, and oblique fracture cannot be inserted in transverse fracture. Now, inserting it at 90 degree or very close to 90 degree is absolute necessary, because if you insert it at other angle with a more obtuse or a more acute angle, it will cause displacement of your fragments. How? It is shown in this diagram. So the bone is reduced by reduction clamp. A leg screw is inserted at 90 degree will give compression at the fracture site. It is inserted at 90 degree, not doing anything. It is not inserted at 90 degree. It is inserted at angle of 120 or 130 degree, cause displacement of the fracture fragment. By the compression it gives, it actually displaces the fracture fragment, cause it is providing force for the fracture to displace rather than to compress. Okay, so it should be inserted at 90 degree or as close to 90 degree. What are this? A neutral screw at one side and eccentric screw at other side of the plate. We'll discuss with a diagram in this talk only, but the detailed video will come later on. So the direct healing, we know that there should be no motion at the fracture site under physiological loading. And for articular fractures it can be done for simple wedge type of fracture. It heals without callus formation, primary bone, also known as primary bone healing. Contact between the fracture end is necessary and is required anatomical reduction, which was not necessary to achieve indirect fracture healing. It can be achieved by leg screw, compression plate, buttress plate, and TBW. So this is the compression plate which was done for the shaft of humerus to achieve direct healing. This is the articular distal and radius fracture which is fixed with the plate to achieve direct fracture healing. This is a TBW done at the medial malleolus. This is the medial malleolus fixation done to achieve direct healing. This is a plate for intra-articular tibia fracture. This is a buttress plate actually. What is buttress plate? We'll discuss on the next diagram, and it will also heal by direct healing. So again, I told you that the detailed video about plating, what kind of plates, what are derotation plate, what are neutral plate, what are buttress plate, what are bridge plate, neutral plate, will come later on. But this diagram is essentially to understand where which kind of healing occur and why which kind of healing occur. So first we'll start with buttress plate. What is buttress plate? What is buttress plate? So if this is the bone and here the fracture is happening, the force it has, this fracture tend to collapse downwards. So what you do is you just put a dhakka on this fracture. Don't fix this fracture, don't put anything on this, you just put a dhakka on this. What we do, we put a plate like this, put screws and distal fragment, and now this contact is providing a dhakka to this in this direction, which has two components. One is this force and one is this force. So this dhakka which was provided to this fragment, to this fracture fragment, is essentially called buttress. So this is the mechanism how this plate works. So this is the buttress plate where you put this screw first. So it kind of put dhakka on this fracture fragment. This is called buttress plate. Now comes to compression plate. What is compression plate? To understand what is compression plate, we first have to understand what is centric screw and what is eccentric screw. So let's talk about this hole in the plate. I just draw this hole in the plate. So this hole in the plate diameter is more than the screw diameter. As you can see, there are voids even after inserting the screw. So you can insert the screw in the hole at this place also or at the edges also. At any place you can insert the screw. If you insert the screw at the center, they are called as centric screw. If you insert the place at not at the center, at the edges, it's called eccentric screws. Understand what a centric screw and what is eccentric screw. Now how the combination of a centric screw and eccentric screw is used to achieve compression is actually the science behind the compression plate. Simple. Very simple. So suppose this is the fracture fragment. This is the fracture fragment which you have. You put a centric screw here and you put a eccentric screw here to pull this fracture here. To pull this fracture here. This is the science behind the compression plate. Okay. So B is a neutral screw, which is centric screw. C is a leg screw. You can see it is inserted at 90 degree. And E is a compression screw, which is inserted at the distance place. So since it is inserted here, it will cause pulling of the bone to that place. It will cause force applied which pull the bone here. This essential mechanism is called compression. A detailed understanding of mechanics behind the compression plate. Well, the video will come in a week. Next is a bridge plating. Now, how is bridge plate and what is bridge plate? Suppose you have a bone which got fractured. This is one fragment, this is comminuted fragments, this is another fragment. You just put a plate through and through without involving the screw in the comminuted fragment. You just bridge the comminuted fragment and fix the plate to the proximal and distal non-comminuted fragments of the fracture. This kind of plating is called as bridge plating. Now the neutralization plate. Neutralization plate is a plate where all screws are centric screws. No eccentric screw is inserted to achieve compression. Okay, it is mostly used along with a leg screw, because the leg screw is the one which has give the compression at the fracture side, and neutralization plate is just to provide or to augment the stability at the fracture side. So now understanding of these plates and how these plates work will actually discuss in detail later on, but the goal was to understand where which kind of fracture healing occur. So first, buttress plate, it heals by direct fracture healing or primary fracture healing. Compression plate, it again heals by primary fracture healing or direct fracture healing. Neutralization plate, because there is also a leg screw, it heals by primary fracture healing or direct fracture healing. Bridge plating actually has no absolute stability at fracture site. There is comminuted fragment which will have micromotion and will heal with callus formation. So here it is the indirect fracture healing which will happen, also called as the secondary fracture healing. Got the point? So it is not the concept that plating always cause direct fracture healing. There are scenarios where plating could cause indirect fracture healing also. So the key point, direct fracture healing, it is called as a primary fracture healing, occur in the situation of absolute stability. It is biomechanically inferior than indirect fracture healing. It occurs without callus formation. Indirect fracture healing is secondary fracture healing, which occurs in a condition of relative stability. It is biomechanically superior and occur with callus formation. Factors affecting fracture healing will come in the next video. So we have discussed them all, direct fracture healing and indirect fracture healing. Hope so you're good with it. The points which I have told you will come in the upcoming time. I'll try my best to get the video to you delivered as soon as possible, and thank you.